Welcome everyone to Florida Atlantic University and the presentation, Everything in Our Universe is One. Everything in our universe is one because everything in our universe is a child of the superforce or mother particle. There are fundamental matter particles like the electron in you, me, the Empire State Building, Mount Everest, our Earth, our Moon, our Sun, and in all the stars. And these fundamental matter particles are all children of the superforce or mother particle. Everything in our universe is one is based on a theory of everything, which is the most complicated theory in physics. Both Einstein and Hawking worked on the theory of everything, and they were not able to solve it, even though they spent most of their lives working on it. But today, I'm going to teach you the fundamentals of an integrated theory of everything so you can go home and explain it to your family and friends. And if you have an obnoxious physicist friend, like a Sheldon Cooper, you can teach it to him also. And everyone will think you're a genius. The foundations of an integrated theory of everything are 20 independent existing theories like string theory and particle creation. The reason why they're independent is the physicists who worked on string theory did not talk to the physicists who worked on particle creation, so we have 20 independent theories. Each of these independent existing theories was selectively amplified, and the premise of an integrated theory of everything is without sacrificing the 20 independent existing theories, they were replaced by 20 amplified interrelated theories, and that is in Table 4, and that's one of the last charts in the presentation. Now, another way of looking at the problem is if you think of these 20 independent theories of being jigsaw puzzle pieces, initially they don't fit together because they're independent of each other. But by amplifying the requirements of each of the theories, that's equivalent to amplifying the size and shape of the jigsaw puzzle pieces such that they fit together. And that will be shown to you as the jigsaw puzzle figure, which is at the end of the presentation. Now, only 5 of the 20 theories will be discussed, and they include particle creation, the Higgs force, also known as the Higgs boson or God particle, string theory, the superuniverse, also known as the multiverse or parallel universes, and stellar black holes. An integrated theory of everything unites all known physical phenomena from the infinitely small at the Planck cube scale to the infinitely large at the superuniverse scale. Now, what exactly is a Planck cube? A million is a 1 followed by 6 zeros. A billion is a 1 followed by 9 zeros. A trillion is a 1 followed by 12 zeros. A googol is a 1 followed by 100 zeros. A googol is an infinitely large number. A Planck cube is infinitely small because almost a googol of Planck cubes fits in each grain of sand. A Planck cube is infinitely small because almost a googol of Planck cubes fits in each grain of sand. Now, if you go to Legoland, you will see objects constructed out of Lego blocks. I recommend going to Legoland because it's entertaining, it's educational, and there's a gourmet restaurant 5 miles from Legoland. Now, if you go to Legoland, you will see an Empire State Building, a bust of Einstein, and an encyclopedia, all made up of these Lego blocks. And I want you to imagine shrinking the Lego blocks until they become the size of an infinitely small Planck cube, and then we will be able to define any object in the superuniverse as a volume of contiguous Planck cubes. So we can visualize the Empire State Building, Einstein, you, me, an encyclopedia, a stellar black hole, or the entire superuniverse made up of these infinitely small Planck cubes. Now, this is an example of an encyclopedia's Planck cubes. This is the encyclopedia, and these are the Planck cubes. Now, the figure is not to scale because Planck cubes are infinitely small. So I want you to imagine the Planck cubes being shrunk in size until they become the size of an actual Planck cube, and then we will have defined an encyclopedia made up of infinitely small Planck cubes. Now, what is a superuniverse? First of all, our universe is an enormous sphere which has a radius of 300 billion trillion miles. And in our universe, there are 100 billion galaxies uniformly distributed in our universe, and each of these galaxies contains 100 billion stars. One of those galaxies is our Milky Way galaxy, and one of the 100 billion stars is our sun. The superuniverse is infinitely large because it contains over a googol of parallel universes the size of our universe. The superuniverse is infinitely large because it contains over a googol of parallel universes the size of our universe. Now, the model I use for the superuniverse is a modified gumball machine, where the gumballs are the universes, and the gumballs are spherical in shape but are of different sizes. So we have this infinitely large gumball machine. One of those gumballs is our universe, and outside of our universe are all these other gumballs which are spherical in shape but different sizes, and they represent the parallel universes. Now, the question you may ask is, if this is our universe and all the parallel universes, all the gumballs are outside of our universe, how come no one has ever seen a parallel universe? And there are two reasons for that. First of all, our universe is really an enormous sphere which has a radius of 300 billion trillion miles. And the other reason is the most powerful telescope we have on Earth, the Hubble Space Telescope, can only see 90 to 95% of our gumball, our universe. It cannot see the last 5 or 10% of our universe. It cannot see the edge of the gumball or the boundary of our universe, and therefore it cannot see over the boundary to detect these other gumballs outside of our universe. Now, this is a figure of the superuniverse. Here is our universe, and our universe is nested within a precursor universe, and both of those are nested within the superuniverse. The figure is not to scale because, as I said before, the superuniverse contains over a googol of parallel universes the size of our universe. Now, using the gumball machine as the model, one of those gumballs is our universe. A subset of the gumballs is the precursor universe, and one of the gumballs in that precursor universe is our universe. And the entire gumball machine is the superuniverse. There are 5 fundamental matter particles which make up everything in our universe. And they're divided into 2 types: atomic matter, which is visible, and dark matter, which is invisible. If you can see the object, it's made of atomic matter. So you, me, the Empire State Building, Mount Everest, our Earth, our Moon, our Sun, and all the stars are visible. So they're made out of atomic matter. At the first level are molecules like the water molecule and the carbon dioxide molecule. At the second level, we can take the molecules and break them down into their constituent atoms. For example, water is H2O, 2 hydrogen, 1 oxygen atom, and carbon dioxide is 1 carbon and 2 oxygen atoms. At the third level, we can take the atoms and break them up into their constituent parts, which are protons, neutrons, and electrons. The protons and neutrons are in the center of the atom, and the electron is in orbit about the nucleus. So a hydrogen atom has 1 proton in the center and 1 electron in orbit about it. The helium atom has 2 protons, 2 neutrons in the nucleus, and there are 2 electrons in orbit. At the fourth level, we can take protons and neutrons and break them up into their constituent parts, which are up quarks and down quarks. 1 proton equals 2 up quarks and 1 down quark, and 1 neutron consists of 1 up quark and 2 down quarks. The second type of matter is invisible, and that's called dark matter. It was originally proposed to account for the missing mass in galaxies. When astronomers started to analyze the motion of the 100 billion stars rotating about the center of the galaxy, they realized there was not enough gravitational force, enough atomic matter, to provide the gravitation to keep those stars in orbit about the center of the galaxy. So they proposed dark matter to provide the additional gravitational force to keep those 100 billion stars rotating about the center of the Milky Way galaxy. At the fourth fundamental level, dark matter consists of the xeno and photino. No one has ever seen a xeno or photino. They're actively looking for them at the Large Hadron Collider in Geneva, but to date, no one has seen either a xeno or a photino. So there are 5 fundamental matter particles that make up all the matter in our universe: the up quark, the down quark, the electron, the xeno, and the photino. Now there are 2 force or energy particles, and the most important one is the superforce or mother particle. All other matter and force particles were created from the superforce or mother particle. In the early universe, particle creation was very similar to the 3 phases of water. For example, if you decrease the temperature, you can condense steam into water, and if you continue to cool it to 32 degrees, you can freeze it or condense it into ice. And this is a 2-way process. If you decrease the temperature, it works. If you increase the temperature, it also works. So if you increase the temperature of ice to 32 degrees, it melts or evaporates the water. And if you continue to heat it to 212 degrees, it evaporates the water to steam. Now, particle creation in our early universe was very similar to that. As our universe expanded, the temperature decreased. And therefore, the superforce or mother particle at 5 high temperatures condensed first to the up quark matter particle, then to the down quark matter particle, then to the electron matter particle, to the xeno matter particle, and to the photino matter particle. The superforce, the up quark, the down quark, the electron, the xeno and photino are all the same thing, but they manifest themselves differently at different temperatures. Just like H2O manifests itself as steam, water, and ice. The same thing, but they look different at different temperatures. Now, the second force is called the Higgs force, also known as the Higgs boson or God particle. And what that is as follows. A matter particle and the Higgs force are one and inseparable. And the model I use is an underweight porcupine with overgrown spines. The underweight porcupine represents, for example, an up quark matter particle in a Planck cube, and the overgrown spines are the 3-dimensional Higgs force that is permanently attached to that matter particle. No matter where the matter particle goes, the Higgs force goes with it. You cannot have the matter particle without the Higgs force, or the Higgs force without the matter particle. So therefore, when the temperature decreased in the early universe, the superforce condensed into 5 matter particles and their 5 associated Higgs force. So the superforce initially condensed into the up quark matter particle and its Higgs force, into the down quark matter particle and its Higgs force, into the electron matter particle and its Higgs force, into the xeno matter particle and its Higgs force, and into the photino matter particle and its Higgs force. And just like water, it's a two-way process. You can either decrease the temperature or increase the temperature. And I will show you an example in our precursor universe of a supermassive quark star matter where the temperature is increasing. So what happens in that case is the up quark matter particle and its Higgs force evaporate up to the superforce. The down quark matter particle and its Higgs force evaporate to the superforce. The electron matter particle and its Higgs force evaporate to the superforce. The xeno matter particle and its Higgs force evaporate to the superforce. And the photino matter particle and its Higgs force evaporate to the superforce. Now hang in there, we're almost there. And by now, each of you is smarter than Einstein or Hawking in an integrated theory of everything. Okay, this is an up quark string in a Planck cube, and I want you to imagine the creation of this as follows. We're going to start with an infinitely small Planck cube, and we're going to take an infinitely small beach ball and put it in the Planck cube. So this is the beach ball, and it's going to just touch the 6 sides of the Planck cube. Then we're going to take that beach ball and put periodic surface hills and valleys in it. We're going to take a sticky rubber band, wrap it around that beach ball, and the shape of the rubber band will be the shape of an up quark string in a Planck cube. And you can see it has 1, 2, 3, 4 hills, and 1, 2, 3, 4 valleys, and they correspond to those surface hills and valleys on the beach ball in the Planck cube. Now, I went through the 4 levels of matter. We went from molecules to atoms, to protons, neutrons, electrons, to up and down quarks. At the 5th level, all matter particles and force particles are strings in a Planck cube, and the only difference between them is the amplitude and frequency of the hills and valleys. So, for example, if the up quark string has 1, 2, 3, 4 hills and 1, 2, 3, 4 valleys, if we double the number of hills, so we have hill 1, 2, 3, 4, 5, 6, 7, and 8, and between the 8 hills we put 8 valleys, that could represent a down quark. So the only difference between an up quark and a down quark is the number of hills and valleys on that beach ball. Furthermore, in the extremely high temperatures at the start of our universe, all 5 matter particles, the up quark, the down quark, the electron, the xenon, photino, and their 5 associated Higgs forces all become superforce or mother particles. And they're all in a donut-shaped singularity or point at the center of a single Planck cube. And this is the donut-shaped singularity or point, and this is a Planck cube. Now, the figure is not to scale because Planck cubes are infinitely small. But what I've done is I've amplified the Planck cube so you can see it and this donut-shaped singularity at the center of the Planck cube. At the beginning of our universe, at time t equals 0, everything in our universe was in the form of superforce or mother particles in this donut-shaped singularity or point. At the beginning of our universe, at time t equals 0, every up quark, down quark, and electron in your body, which are the basic building blocks of all atoms and molecules in your body, each of your up quarks, down quarks, and electrons were in the form of superforce or mother particles. As were all the up quarks, down quarks, and electrons in my body, and those in the Empire State Building, Mount Everest, our Earth, our Moon, our Sun, in all 100 billion stars, and in all 100 billion galaxies. At time t equals 0, everything in our universe was in the form of superforce or mother particles. They were stacked one atop of another in a donut-shaped singularity at the center of an infinitely small Planck cube. Now, most people have trouble imagining enormous Mount Everest being squeezed into a donut-shaped singularity or point at the center of an infinitely small Planck cube. So for emphasis, I will repeat the definition. At time t equals 0, every up quark, down quark, and electron in your body, which are the basic building blocks of every atom and molecule in your body, each of your up quarks, down quarks, and electrons were in the form of superforce or mother particles, as were all the up quarks, down quarks, and electrons in my body and those in the Empire State Building, Mount Everest, our Earth, our Moon, our Sun, in all 100 billion stars in our Milky Way galaxy, and in all 100 billion galaxies. At time t equals 0, at the beginning of our universe, this is what our universe looked like: a donut-shaped singularity consisting of superforce particles stacked one atop of another at the center of an infinitely small Planck cube. Now, I've taken you down through the decomposition of matter. We went from molecules to atoms to proton, neutrons, electrons, to up and down quarks, and then I said at the fifth level, all matter particles and force particles were strings, and I said if you raise the temperature of the strings to the temperatures early in our universe, they were all superforce or mother particles in a donut-shaped singularity. And now I'm going to take you in the opposite direction. I'm going to start with the superimposed superforce particles in the donut-shaped singularity, and I'm going to show you how from those up quarks and down quarks were created, how from those protons and neutrons were created, how from those atoms were created, how from those stars were created, how from those molecules were created, how from those simple life cells were created, how from those multiple life cells were created, and how from those fish, amphibians, land mammals, and humans were created. And that is on our universe's timeline, which starts at time t equals 0, the beginning of our universe, and the present time is 13.8 billion years after the Big Bang. At time t equals 0, our universe consisted of superforce or mother particles stacked one atop of another in a donut-shaped singularity or point at the center of an infinitely small Planck cube. Within the first millionth of a billionth of a billionth of a billionth of a second, matter creation began. The superforce began condensing into up quark matter particles and their Higgs forces, into down quark matter particles and their Higgs forces, into electron matter particles and their Higgs forces, into xeno matter particles and their Higgs forces, and into photino matter particles and their Higgs forces. And at that time, inflation occurred. Inflation is the exponential increase in the size of our universe in the first millionth of a billionth of a billionth of a billionth of a second. Within the first thousandth of a second, two up quarks and a down quark combined to form a proton, and one up quark and two down quarks combined to form neutrons. By 100 seconds after the Big Bang, that was the end of matter creation. that donut-shaped singularity of superforce particles had disappeared because all of the energy in our universe had been condensed into up-quark matter particles and their Higgs forces, into down-quark matter particles and their Higgs forces, into electron matter particles and their Higgs forces, into xenomatter particles and their Higgs forces, and into photinomatter particles and their Higgs forces. At 200 seconds after the Big Bang, 2 protons and 2 neutrons combined to form helium nuclei. So at this time we had the nuclei of 2 atoms. We had the nucleus of the hydrogen atom, which was a single proton, and the nucleus of a helium atom, which were 2 protons and 2 neutrons. At 30,000 years after the Big Bang, dark matter, the xeno and photino, began to clump together. So we had our universe, and initially the xeno-photino matter particles were uniformly distributed in our universe. At 30,000 years, they became gravitationally attracted to each other, and they started to form lumps of xeno-photino matter particles in our universe. And over 100,000 lumps were created, and those 100,000 lumps, the nodes or locations of those, became the location of the 100 billion galaxies in our universe. At 380,000 years after the Big Bang, atomic matter, the hydrogen, began to clump together. So we had these clumps of xeno-photino matter particles, and we had these hydrogen molecules uniformly distributed. And at 380,000 years after the Big Bang, the hydrogen molecules became attracted to these lumps. And what happened is we formed clouds of hydrogen molecules interspersed with the dark matter particles, the xeno and the photinos. At 200 million years after the Big Bang, the first stars and all the other atoms were created. So we had, for example, one of these clouds of hydrogen molecules interspersed with xeno-photino matter particles. And at the center of the cloud, there were 2 hydrogen molecules, and they were subjected to the weight or pressure of everything above them, all the hydrogen molecules and the dark matter, xeno-photino matter particles. And that was sufficient to take those 2 hydrogen molecules, fuse them together, ignite them, and those were the creation of the first stars, and there were over 100 billion of these stars created, and that was the beginning of the 100 billion galaxies in our universe. Now, there were 2 processes that occurred, stellar core and supernova explosion. And as a result of those 2 processes, all the atoms in the periodic table above hydrogen and helium were created. Carbon, oxygen, silicon, gold, silver, and lead. So if you're wearing any gold piece of jewelry, that gold was initially formed in the creation of the first star of our Milky Way galaxy. So the gold in your jewelry is over 13 billion years old. At 2.6 billion years after the Big Bang, the 2 most important molecules were created, water and carbon-based life molecules. Water is H2O, and the carbon-based life molecules are carbon, oxygen, hydrogen, and nitrogen. The water molecules are basically formed in comets, which are ice balls or snowballs, and the carbon-based molecules form primarily on asteroids, which are small planetary bodies. At 9.2 billion years after the Big Bang, or 4.6 billion years ago, our solar system was created. So once again, we have this hydrogen cloud, and interspersed in the cloud were the dark matter, xeno-photino matter particles, plus all of the atoms that had been created by stellar core and supernova explosions, oxygen, nitrogen, silicon, gold, silver, and lead. And at the center of the cloud, there were these 2 hydrogen molecules, and they were subjected to the weight or pressure of everything above them, and that was sufficient to fuse the two hydrogen molecules together, ignite them, and that was the creation of our sun. And everything in that cloud above those two hydrogen molecules became either the sun itself or the planets which started to rotate about the sun. At 10.3 billion years after the Big Bang, simple life cells were created. When the Earth was created, it contained neither water or carbon-based molecules. The water came to the Earth from these comets. The comets bombarded the Earth, and that's where the oceans came from. The carbon-based molecules came in from asteroids, which also bombarded the Earth. So at this time, 10.3 billion years after the Big Bang, we had the three ingredients required for life: water, carbon-based molecules, and the heat of the Earth. And that caused simple life cells to be created, and over the next several billion years, they evolved into multiple cell lives, and from that into fish, amphibians, land mammals, and human beings. At 13.6 billion years after the Big Bang, or 200 million years ago, the first modern humans appeared in Central East Africa. They began to migrate north. They crossed the Arabian Peninsula and settled in an area north of the Black Sea. There were three migrations from that area. One migration went west to populate Europe, Greece, and eventually Great Britain. Another group went southeast to populate India, Southeast Asia, the Southeast Asian islands, and eventually Australia. And the third group went northeast into China, Siberia, eventually into Alaska, North America, and South America. And 13.8 billion years after the Big Bang, we and our universe exist. And it all started 13.8 billion years ago with a donut-shaped singularity consisting of superimposed superforce or mother particle strings at the center of a single infinitely small Planck cube. Now, what are stellar black holes? The official definition is a stellar black hole are stars or suns which are so dense that light cannot escape from them. A more practical definition is as follows. Just as our sun and its gravity holds the planets as they rotate about the sun, at the center of our Milky Way galaxy is a supermassive black hole, and it is its gravity that holds the 100 billion stars rotating about it in orbit about the center of the galaxy. The supermassive black hole at the center of our Milky Way galaxy is called Sagittarius A, and it has a mass of 4 million suns. So what that means is, from the time our Milky Way galaxy was created, when at the center of it was a small black hole, over the next 13.6 billion years, 4 million suns or stars were swallowed or fell in to that black hole, and now it is a supermassive black hole, strong enough to hold the 100 billion stars in the galaxy in orbit about our Milky Way center. Now, I want you to imagine a gigantic compact, and the compact I have in mind is the hydraulic compactor in junkyards. If you have an old car and you bring the car into the junkyard, they'll take the engine block out, they'll put it into a hydraulic compactor, and they'll squeeze it down to a cubic yard of metal. Now, our gigantic compactor works the same way. However, no matter how large the object, this compactor will squeeze it down to a very small size. So we'll start with the state of Florida. We'll take all of the condominiums in Miami Beach, the Kennedy Space Center, Lake Okeechobee, and the city of Orlando. And we'll put everything into this compactor and squeeze it down. Then we'll take everything in the United States. We'll take all of the skyscrapers in Manhattan, the Brooklyn Bridge, the Manhattan Bridge, the Verrazano Bridge, the Appalachian Mountains, Gateway Arch in St. Louis, the Great Lakes, all of the Rocky Mountains, and the three cities of Seattle, San Francisco, and Los Angeles, and we're going to put it into this gigantic compactor and squeeze it down. Then we'll take everything in the world. We'll take the Great Wall of China, the Himalayan mountains, Mount Kilimanjaro, all the oceans of the world, and all 7 billion inhabitants, and put them into this compactor and squeeze everything down. Then we'll take everything in our solar system, our sun, our earth, our moon, all the planets, all of the asteroids and comets in our solar system, of which there are trillions. We'll put them into this gigantic compactor and squeeze everything down. Then we'll take everything in our Milky Way galaxy. Each of 100 billion stars has its own set of planets. Each planet has its own set of satellites. Each solar system has a set of comets and asteroids. We'll take everything in the Milky Way galaxy and put it into this compactor. And then we'll take everything in the 100 billion galaxies. Each galaxy has 100 billion stars. Each star has its own set of planets. Each planet has its own satellites. All of the comets and asteroids. We'll put everything in our universe into this gigantic compactor, and we're going to squeeze it down to a donut-shaped singularity or point at the center of an infinitely small Planck cube. The gigantic compactor is a stellar black hole, and it can take any object, no matter how large, and squeeze it down to a very small volume. So if we went over to the enormous Mount Everest and we picked up the mountain and we carried it over and dropped it into a stellar black hole, instantaneously the temperature of Mount Everest would be raised to trillions of 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 degrees, and Mount Everest would instantaneously evaporate to superforce, or mother particles, and be rammed into a donut-shaped singularity or point at the center of an infinitely small Planck cube. The unimaginable power of a stellar black hole. Now, what is revolutionary about that gigantic compactor that I just described is the existence of a supermassive quark star matter black hole in our precursor universe. At the beginning of the presentation, I showed you a sketch, and I showed you our universe, and then that was part of a precursor universe, which was a subset of the gumball, and then the entire gumball machine was the super universe. So our precursor universe exists now, but it also existed before the creation of our universe. 13.8 billion years ago, our universe didn't exist, but the super universe and the precursor universe did. And these are the two types of supermassive stellar black holes that existed in our precursor universe more than 13.8 billion years ago. The first one is called a supermassive quark star matter, and that existed 1 second before the start of our universe. And the second was a supermassive black hole energy that existed at time t equals 0, and that was the donut-shaped singularity or point at the center of an infinitely small Planck cube. Now, in this diagram, these squares represent Planck cubes. But once again, the figure is not to scale because Planck cubes are infinitely small. So I want you to imagine shrinking these squares down until they become the size of a Planck cube, and then we will have defined a stellar black hole, namely a supermassive quark star matter, as a volume of infinitely small Planck cubes. Now, there are two letters in these Planck cubes. One is M, and the other is H. M stands for matter, And there are 5 types of matter particles, and they are the up quark, the down quark, the electron, the xeno, and the photino. And H stands for Higgs force, and there are 5 types of Higgs forces. The Higgs force associated with the up quark, the Higgs force associated with the down quark, the Higgs force associated with the electron, the Higgs force associated with the xeno, and the Higgs force associated with the photino. Now, 1 second before the Big Bang, this supermassive quark star matter swallowed one additional matter particle. And that was the straw that broke the camel's back. Because what happened at 1 second before our universe was created, this supermassive quark star matter evaporated, deflated, and collapsed to a supermassive black hole energy, or the donut-shaped singularity at the center of a Planck cube. And that was the input to our universe. Now, this table shows the precursor universe justification, and there are 3 columns. The first one has 3 laws of physics. The second is the ultimate free lunch theory. That is the prevailing theory of cosmology, or how our universe was created. And this is believed by 90 to 95% of physicists today. And the third column is an integrated theory of everything. That's an alternative form of cosmology. And I'm proposing that an integrated theory of everything replace the ultimate free lunch theory, because an integrated theory of everything satisfies all 3 of those laws, whereas the ultimate free lunch satisfies only one. Now, what exactly is the ultimate free lunch? The ultimate free lunch states that before our universe, before time t equals 0, there was nothing, 0. And miraculously, at time t equals 0, from nothing, all the energy of our universe was created. And that amount was 10 to the 54th power kilograms of energy. 10 to the 54th means a 1 followed by 54 zeros. So it's a near infinite amount of energy. So what the ultimate free lunch theory is saying is that the energy mass in you and me, in the Empire State Building, in Mount Everest, in our Earth, our Moon, our Sun, in all the stars and in all the galaxy, that all of that came from nothing. And hence the name, the ultimate free lunch. From 0, the near infinite energy of our universe was created. Now, I'm going to go through the 3 laws to show how these 2 theories of cosmology, or the start of our universe, compare. Conservation of energy mass. What that law states is that over a period of time, the amount of energy mass is a constant, although the form may change. When I talked about the timeline of our universe, I said at time t equals 0, there was a donut-shaped singularity or point at the center of a single Planck cube. And its energy mass was 10 to the 54th kilograms. I also said in that chart that 100 seconds after the Big Bang, that donut-shaped singularity had disappeared, because all of the energy had been condensed into up quark matter particles and their Higgs forces, into down quark matter particles and their Higgs forces, into electron matter particles and their Higgs forces, into xeno matter particles and their Higgs forces, and into photino matter particles and their Higgs forces. And if I had calculated the energy of all those 5 matter particles and the Higgs forces, I would have gotten the same 10 to the 54th kilograms of energy. And now, 13.8 billion years after the Big Bang, if I were to calculate the energy mass in you and me, in the Empire State Building, in Mount Everest, in our Earth, our Moon, our Sun, in all the stars and in all the galaxies, I would get the same number, 10 to the 54th kilograms of energy. So over the last 13.8 billion years, the amount of energy mass in our universe has been constant, 10 to the 54th kilograms, although the form changed over time. Now, the ultimate free lunch theory violates the conservation of energy mass when you go from minus 1 second before the Big Bang, to the Big Bang. Of course, what they're saying is 1 second before the Big Bang, there was 0. And then at the time of the Big Bang, miraculously, 10 to the 54th kilograms of energy was created. In contrast, in an integrated theory of everything, it satisfies that, because what I'm saying is 1 second before the Big Bang, there was a supermassive quark star matter, and its energy mass was 10 to the 54th kilograms. When it swallowed one additional matter particle, it evaporated, deflated, collapsed to a donut-shaped singularity at the center of a single Planck cube, and that was also 10 to the 54th kilograms, and that was the energy that was transferred to our universe. Now, the second law is Einstein's theory of general relativity. And what Einstein said was, in the precursor universe, there was a black hole which swallowed matter and energy. And in our universe, there was a white hole. A white hole expels matter and energy. And connecting the black hole and the white hole was a wormhole or donut-shaped singularity at the center of a single Planck cube. Now, in science fiction, a wormhole is described as follows. You have the precursor universe on one side, our universe on the other side, and they're connected by a tunnel-like device called a wormhole. And spaceships are going back and forth between the two universes. No, no, no. That's the science fiction definition of wormhole. The wormhole in reality is that ubiquitous donut-shaped singularity or point at the center of a single Planck cube. And what's happening is, in the precursor universe, the matter particles and force particles evaporate and go into the donut-shaped singularity as superforce particles. And then, as our universe expands, the superforce condenses into matter and force particles. So, the ultimate free lunch theory violates Einstein's theory of general relativity, because in that theory, nothing existed before time t equals 0. But an integrated theory of everything satisfies, because just as Einstein predicted, there was a black hole in a precursor universe, there was a white hole in our universe, and they were connected by this wormhole. Now, the second law of thermodynamics basically says that disorder or entropy increases as a function of time. And both the two theories of cosmology satisfy that. So, once again, I'm proposing that an integrated theory of everything replace the prevailing ultimate free lunch theory, because the integrated theory of everything satisfies 3 laws of physics, whereas the ultimate free lunch satisfies only 1. Now, if your obnoxious physicist friend insists that the ultimate free lunch is still correct, you refer him to me, and I will straighten him out. At the beginning of the presentation, I said there was an integrated theory of everything jigsaw puzzle. The unshaded areas represent the 20 independent theories, and you can see that the unshaded areas don't fit snugly together. So what I did over 7 years is I amplified requirements for each of the theories, and by doing that, I amplified the size and shape such that I had 20 jigsaw puzzle pieces that fit together. And one example of an amplified requirement is, when I described the Higgs force, I said it was the matter particle and the Higgs force were one and inseparable. You could not have a matter particle without the Higgs force, or the Higgs force without the matter particle. I also mentioned at the beginning of the presentation this table 4 primary interrelationship between 20 integrated theories. When I started the analysis 7 years ago, I had 20 independent existing theories in the first column and in the first row, and the table was blank because there were 20 independent theories and they were independent of each other. But after 7 years of analysis and 150 iterations, the 20 independent existing theories in the first column and first row were replaced by 20 interrelated amplified theories. I found all of these relationships and created an integrated theory of everything. Everything in our universe is one. Every animate or inanimate object that exists or ever existed is your cousin. I am your cousin. Abraham Lincoln is your cousin. The dinosaurs are your cousins. Poison ivy is your cousin. And all 100 billion galaxies in our universe are your cousins. Why? Because at time t equals 0, every up quark, down quark, and electron in your body, which are the basic building blocks of all atoms and molecules in your body, they were in the form of superforce or mother particles, as were every up quark, down quark, and electron in my body, in those in Abraham Lincoln, in dinosaurs, in poison ivy, Mount Everest, and in all the galaxies. At time t equals 0, at the beginning of our universe, everything in our universe was in the form of superforce or mother particles in a donut-shaped singularity or point at the center of an infinitely small Planck cube. And now I have that trick test question for you. And the question is, if your mother was a superforce particle and my mother was a superforce particle and both mothers were sisters, who was our grandmother? I mentioned in the precursor universe there were two types of supermassive stellar black holes. The first one was a supermassive quark star matter that existed 1 second before the Big Bang. And the second one was a supermassive black hole energy, and that was the donut-shaped singularity at the center of a single Planck cube. I also said at 1 second before the Big Bang, this supermassive quark star matter swallowed one additional matter particle, and that caused the supermassive quark star matter to evaporate, deflate, and collapse to the supermassive black hole energy, or the donut-shaped singularity at the center of a single Planck cube. This donut-shaped singularity contains the superforce or mother particle, and that was our mother, and our grandmother was the supermassive quark star matter. Everything in our universe is one because everything in our universe is a child of the superforce or mother particle. We are the superforce. My book is called Master Big Bangs Through Black Holes in 4 Hours. It's an integrated theory of everything introduction. It's available in either hard or electronic copy from Amazon.com, and it's also available at other retail outlets like Barnes and Nobles. Thank you.